was going to hit record and then I forgot to. Okay, so again, right, F equals K Q1 Q2 over D squared, right? That's the force. K is our constant value. Here are our charges for charge A, for charge B, and the distance apart. We're asked to find the force of A on B. So I'm going to write it this way for part A, question for part A, the force of A on B, right? And we're just going to, should be easy. A lot of button pushing because all that scientific notation, but it should be easy. Just plug and chug into our formula, right? K is constant, 9 times 10 to the 9th. Q1 will be A, 6 times 10 to the negative 6th. Q2, the charge of B, 3 times 10 to the negative 6th over D squared, all over D 0.03 squared. Right? And now it just becomes a matter of algebra and button pushing. Right? And again, I emphasize to you, use your parentheses. Right? Use your parentheses, including here, including there. Use your parentheses. Okay? But it just becomes a matter of button pushing. Right? Order of operations says do the squaring first. 0.03 squared is 0.0009. So we could erase that and write 0.0009, right? Instead of that, right? That's our order of operations. And then multiply, 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 divide. All right? 9 times 10 to the 9th times 6 times 10 to the negative 6 times 3 times 10 to the negative 6 divided by 0.0009 equals. I pushed all my buttons and I got an answer of 180 newtons. All right. For those of you who are pushing your buttons, can someone confirm that I pushed my buttons correctly?
I got 182.
Beautiful. Thank you, John. All right. I appreciate it. Okay. All right. But it's simple. It's just a lot of buttons, right? So that's where the error is most likely to occur, not in the physics, but in the button pushing to do the numbers. Okay. So there's our answer. What force is A applied B? 180 newtons. That's a pretty big force, right? For a pretty small charge, right? -6, right? That's a small charge, right? That's 1, 2, 3, 4, 5, 6. This number, right, is that number. And yet we got a really big force. But they're pretty close to each other, right? Look how small the distance is apart, right? So they're close to each other. That means they can apply a big force to each other, so on. All right, let's go on to question B. Question B is, what is the force of B on A? What is the force of B on A? B on A. Right? So again, there's our formula. we're just doing B first and then A, right? So F is K times 9 times 10 to the ninth force charge B, charge A, all over D squared. Squared, right? I want to make sure that, okay. So let's take a quick look at this, right? Let's take a quick look at this. If we compare the maths we just did for part A, figuring out the force of A on B, to the formula for the force of B on A, what do we see? Is there any significant difference? Other than the order we wrote these numbers? Is there any other difference? No? I hope you're not seeing a difference because there shouldn't be. All right, now let's think about some math before we even push any buttons. Don't push any buttons, Talon. All right, let's just think about math. 9 times 6 times 3, 9 times 3 times 6. Does the order you multiply matter? Right? If I do 4 times 5, I get 20. If I do 5 times 4, I'm going to get 20. So because all I did was I switched the order of the things we're going to multiply. Am I going to get any different answer? I'm not going to get any different answer. So we're not going to push buttons. We know the answer. As soon as we got our answer for the force of A on B, we know the answer of B on A. They always apply the same force towards each other, right? They apply the same force towards each other. The two charges, whatever force A applies to force B applies back on force A, right? The answers are the same. Okay? They are the same force. Okay, so saving ourselves a little bit of work. As long as we keep that in mind, that's really because the only change is the order that we're multiplying, and that doesn't matter mathematically. All right, so the forces are always the same. Okay, question C, which again you can't see in front of you, but I will read it to you, says, what would happen if to the force of one of, excuse me, I can't read. I'm going to start to put my tongue and my brain together this time. What would happen to the force if one of the charges were negative? If one of these were negative, doesn't matter which one, what would happen to our 180? What would it become? Right? It would become a negative 180, right? Because we'd just be multiplying, all the numbers would be the same, but now we'd be multiplying a negative times a positive, right? So we just get negative 180. All right. So that's the only change, right? The fact that if one of the charges, instead of being a bunch of protons, applying a force to a bunch of protons, it would be a bunch of protons applying a force to a bunch of electrons, right? But the values don't change. The numbers don't change. Just the sign becomes negative 180. Which brings us to question D. Again, you guys can't read it, so I will read it to you. What does the sign of the force tell you about attraction and repulsion of the charges? Okay, so the sign of the force when we first did it was positive because Positive times positive gives us a positive. And what do we know about attraction and repulsion? A positive charge and a positive charge. Are they going to attract each other or repel each other? Like charges. They're both the same sign. Is that attraction or repulsion? Repulsion, Giovanna says. That is correct. Like signs repel. And when they're like, what if it was a -6 and a -3? Negative times negative also gives you positive. We would have still gotten a positive 180. And they're still like charges, negative and negative. So they still repel. So if our force is a positive force, that means repulsion. They push each other apart. But if one of them is negative, we get negative 180. And now I have a negative and a positive. And opposite charges, do they repel or attract? Opposite charges attract. Thank you, Talon. Opposite charges attract. So if our force is a negative force, it just means that they pull each other towards each other, as opposed to push each other apart. Okay? This is right? It just kind of tells us about the signs. Okay? That makes sense, everyone? Right? Like charges give us a positive answer, and like charges repel. Opposite charges give us a negative answer, and opposite charges attract. Good? Okay. So we're going to do another example. All right. So I'm going to go back to the PowerPoint and change the slide to example number 2. And instead of moving my camera, I'm just going to write the numbers here on the board for you. All right. The formula doesn't change. This time I'm labeling it as object C and object D. And this time, object C has a charge of 1 times 10 to the -6. And object D has a charge of -3 times 10 to the let's say 5 or 6. It says 5 on this slide. We're going to go with 6. All right. And the force this time, the force is -27 newtons rather. And we're asked first, okay? So this is our next example. Part A of our example. Is this force attractive or repulsive? It's a negative force. So is that attraction or repulsion? What did we just learn? We have a positive charge and a negative charge and a negative force. Are they going to attract each other or are they going to repel each other? They're going to attract each other. Good. So part A, negative force attract each other. Right? Part B, how far apart are the two charges? So now we're going to solve for D. It's the same stuff, just a little bit of a algebra manipulation to solve for D. Right? F equals K Q1 Q2 over D squared. We have K as a constant. We have Q1, Q2, and F, and we're going to solve for D in this one. What is D? is the question, right? So I'm going to just substitute into our formula, right? F is negative 27 is equal to K 9 times 10 to the 9th Q1 1 times 10 to the negative 6. It's 1 times 10 to the negative 6. 1 times anything is itself. So can I just write? Nah, I'll write it out then. 1 times 10 to the negative 6. Q2 negative 3 times 10 to the negative 6 all over d squared. All right. Haley, is this in your way? Can you? No, you're okay. Okay. Right. So now we just got to solve for d. We have to do a little bit more algebra, but it's the same idea. And I'm going to move the camera so you guys can see it. Right. Negative 27. I can multiply all of them together. I got 9 times 10 to the 9th times 1 times 10 to the negative 6th times negative 3 times 10 to the negative 6th. And I get this. Negative 27 is equal to negative 0.027 all over d squared. Right? Now I just got to finish my algebra and solve for d. I can multiply by d squared on both sides. I get 27 is d squared is equal to, and if I multiply by d squared on both sides, it cancels there, and I get negative 27 d squared. I'm going to write it here. I'm running out of space. D squared equals 0.0027. Right? I'm going to divide by negative 27. Oh, I lost my negative sign. I'm going to divide by negative 27 on both sides. They cancel. Negative 0.0027 divided by negative 27, 0.001. So d squared equals 0.001. I'm going to finish this just in time. I don't want d squared. I want d, right? I want d, so I have to take the square root of that answer. Square root of 0.001 is 0.03 meters. Okay, finished just in time. I have 1 minute before the bell rings. Okay, so tomorrow we're going to do a couple more examples, just working our way through it. I don't think it's that hard because it's only one formula. It's just a matter of practicing and button pushing and, you know, doing your algebra. All right, guys, we'll see you tomorrow. Have a good day.